Yeah, hey, hello everybody. My name is Maciej. I'm a software developer at JetBrains, working on the Kotlin Multiplatform tooling team, which brings Kotlin Multiplatform IntelliJ and Android Studio plugin live. But today I don't want to share you the story about the tooling, but about building the actual applications that you can make use of by yourself. So to share with you some background story, every one of us, I guess, need to do the shopping, and so do I. And I like doing this with my family members. And for this, I'd love to have some application to share the shopping queues between us, sync them alive, and to manage them the way that I'd like to have them shared. So I didn't find the proper open source solution for this, so I decided to build my own with the help of Kotlin Multiplatform, as you may guess. And that's how I ended up with the application that can be run on Android, iOS, and web targets, and which business logic is shared, is managed on the server and deployed somewhere live on the web. So I managed to publish this application to the Google Play as a web page. I didn't do this for the App Store because this costs a lot, and I don't recommend this to you, of course. But as long as you do some pet projects and you want to explore the technology, you can still do this for free, because the Google developer account is not that much. Yeah, you can deploy the server still for free on some services hosting that's offering deployment with the Docker images. And I'd like to share with you an example how you can actually do this. So we can end up with a nice looking application that's doing exactly what you want it to do. So for example, here we just get a few screens for creating, joining shopping lists, managing their states, adding some items, and creating some favorites one with the extra options to customize them in the settings. But that's not the core part of the story that we're gonna see today. The core is the technical part, the technical stack that's available there for you, that's being actively developed by different parts of the ecosystem, and that I'd like to share with you today. So we would like to start with the goals, and the main goal is to build the multi-platform app to be reused by different targets. So we would like to make it run on Android, iOS, and web targets, so also in browser, as well as the JVM target. We would like to share a lot of code between clients and server, not to repeat yourself, to have single source of truth for the data models, for the core business logic that you would reuse between those two parts, and for the, let's say, some utilities that you like to define in your code base and you just don't want to repeat yourself. I will show you some tricky parts of the KMP development path where you should definitely look for when you face some errors, and what are the crucial parts there. And I would like to share with you, of course, the repository itself of the project that I built, so you can, in the future, make use of it. You can go there, look how you can actually build similar applications when implementing your own ideas. But the first question that we usually, as developers, have to ask when starting some project is what technology we want to use. So in this case, we ask, why do we even use Kotlin Multiplatform for such scenario? The answer was in the title of the presentation. We just want to reuse a lot of code, and that enables us to quickly iterate on the application itself and improve it over time. The project that I started I don't know, in February or March, and it's deployed for a few months now. I just sharing this with you today on my presentation. But what was expected from it was to make it run on so many platforms. And we can achieve this not only with Kotlin Multiplatform, but also with technologies like Flutter on or React Native. But what's special about Kotlin Multiplatform is that it gives you the full control of which part of the code are shared. So in this case, we speak about full application written in Kotlin. So you have single source of truth for the logic and the UI. But with Kotlin Multiplatform, you can also build, for example, only the logic. So for example, the view models in Kotlin, and then bring native UI on each of the platforms using the native languages there, where you would only import the libraries built with Kotlin. Kotlin Multiplatform also allows you to use platform-specific APIs in the corresponding sources, so you can define platform-specific behavior on each of the platform, which is not that simple with other solutions. And you end up with a final executable, which is binary for Android, for iOS, for web, which is code with no extra overhead, like the Dart virtual runtime that you would get with Flutter. The general idea of Kotlin Multiplatform is that you start with the targets that you want to support, and you declare them, and then you try to implement as much as you can of your logic in the common source set, which is kind of a place for your Kotlin files, where you will define the shared part of the logic. And then if you miss some parts, you might try searching for the libraries that already solve those solutions and make use of them also from the common source set. And that's how you build your shared part of the application. But you also can make code behave differently in some concrete places on each of the platform. That's what the actual mechanism is for. It's usually used with the functions, where you define some expect functions to be called in a specific place, and then you provide an actual implementation of those functions for each of the relevant targets. Yeah, as I mentioned, the Kotlin Multiplatform builds for each of the target separately. So just the code that you place in the shared part is reused when compiling to each of them. This is about what this is in general, but the question is, how can I start if I never seen this before? The answer is the documentation improved a lot, and I'd like to share this with you today because that's not obvious, and it wasn't the case like three or 4 years when I was starting my journey with Kotlin Multiplatform. So my colleagues did a really nice job on improving this. They also created a set of libraries that you might explore and make use of them for the Kotlin Multiplatform projects, which is klibs.io website, where you can go and explore just by typing what you need. And once you're familiar with those two, you might try creating the project by your own, just going to the kmp.new webpage and selecting the targets that you're interested in, so you get the project downloaded for you on your machine. Once you unpack it, you may explore its README file, which is kind of entry point for all the developers, and I hope you will find there proper instructions how you could run your application for each of the targets, or how you where the actual code is placed in the project. So it's easier for you to navigate from this point. So what's important about the project generated from this wizard? It's mostly the composed multi-platform projects, which builds the common UI for all of the targets in most of the cases. But you can easily extend it to, for example, behave differently on different platforms. And with the quite recent solution, which is a composed code reload, you can easily see the live updates of the application and see how your changes in code are being reflected in the running application. And that's what we were gonna to do during some short demo. We would create such project, but not from the website, but from the IDE itself, and then try to explore it a bit more with the help of the compose code reload. To do this, I will switch to the IDE, which under the hood uses the same wizard backend as is used for the which is used for the mentioned website, and we might try to create a new project. What's important there is the fact that I installed Kotlin Multiplatform plugin for this, so I can easily generate project with multiple targets included. This is connecting to our servers. We generate those projects, and I got it finally opened. Once it's imported, we can see that it contains a few Gradle modules that we will talk about a bit in a minute. But what I'd like to share with you is an option to how you can see in action, because we selected the desktop target as one of the ones that we're interested in. We get the JVM sourced with the main entry point of our application. And from there, we can do the usual stuff, like launch the JVM application. But what's quite new, we can run this application with compose hot reload. And it launches this application in kind of specific way. So you will have the application for the whole time running, but you can observe how it actually changes when we do changes in code. It's at the beginning, it's just a column of button and some stuff put there, but we can easily iterate on changing it. Let's see the removal, we save, and bam, we see the update. So that's how you can iterate on then adding new stuff, right? We can add new counter with the compose stuff. Yep, we can see the counter value here. This is live. So we can make the next button there, which will increase, it's too much, which will increase the value of the button. Bam, and it's live. This is how you can easily iterate on your project, where the whole project was generated from the wizard, and it should be running on your machine the same as on mine. Going back to the presentation, I like to focus on the technical parts and the details of such multi-platform projects, and share with you some tips about configuring them and making the most of the shared code. So first part is the configuration part of the project, which is about structuring such project. We saw at the downloaded project that there is some shared part, there was some server, and there was some compose app part, which is, in our case, the front-end application. So in this case, the shared part is the core on which all other parts depend on. So both server and clients reuse the same code to build the to for example communicate, to execute some common business logic. Then the shared client, which I introduced in the case of my shopping list app, is somehow special there, because it's a client that is reused by the front ends, but also by the server tests. So integration tests can make use of the single definition of the client, which is defined in this module. This is quite small one. And there we have two other ones which are kind of leaves there, the server and the compose app one, which defines the final executables there. Yeah, there is also the directory structure visible on the slide. So the most outer ones are the Gradle modules like Compose App, Server, Shared, and Shared Clients. We have 4 Gradle modules, and in each of them we have built Gradle HTS file usually to define such a module, but also we have a source directory with a different sources for different platforms where we would define platform-specific behaviors. But what we intend to do is to put as much code as possible in the common main source so it can be shared between all the declared targets. And the way how you define such a targets when playing around with Kotlin Multiplatform is the Kotlin block configuration lambda in build Gradle HTS files, in which you just list those targets to be kind of available by your module. Here we can see the shared part module, which is supposed to be some kind of a library to be reused by the front-end and server part, and in which we would like to support all the targets that we intend to run for. We can configure them, like put or make extra configuration in the Lambda blocks of each of the targets, but in some cases it's as simple as calling simple function as JVM or iOS1. So that's how we state that this module will support those 2 targets. And then once we would like to iterate on our project, we might consider adding more targets, for example. But what's a good approach from my perspective is to do this step-by-step basis. So each time trying to compile your project against all available targets and try to add more that way. In the case of the end user applications, like the front-end one, which is not a library but the final executable, this configuration is a bit trickier because it includes how the declaration of how those targets should be run. So, for example, in the case of the Wasm.js and JS visible at the bottom, we should see that we expect the executable to be built, which is the JS file, to be then included in some indexed HTML of your application. While, for example, for iOS targets, we declare that we will use we want to export the static Xcode framework, which we then can easily use in the Xcode project. That's how you build iOS-specific applications, and that's almost the only solution. What I'd like to share, maybe with some of you who already used this in the past, but there is some kind of new part there, which is the commonization of the Wasm.js and JS targets. So the Compose Multiplatform published, I think, in version 1.9, so quite recently, a common kind of commonization of those 2 into web sources, so you can easily define the application and build it from a single, for example, file, right? Which will run with Wasm, if WebAssembly, if it's supported in browser, and if it's not, it will run the fallback option, which is the JS, which is much slower, but it still works, right? Yeah, and the corresponding parts of those configurations after declaring targets is the part that defines the sources, which is kind of place for you to place your code for the respective targets. And in case of this kind of shared module, we would like to put as much as possible code in the common part. For example, in my shopping list and in the default one, I think most of the code is put in the common main source set. So you could possibly there add some dependencies which supports all of the targets that you intend to export to. But what's important there to understand there, to have kind of better understanding of the technology, the technology there, is to keep in mind that the common source set that you define is somehow commonized to the targets that you declare. So, for example, if you include many targets, let's say each target that Kotlin compiler itself supports, then you might end up in a situation where in common source set you can use only Kotlin standard library, because that's the APIs that's available on all platforms, and even not all APIs from there are available on all platforms. But if you say, okay, I put my code to the common main source set, and you have only Android target, then you could possibly use Android-specific APIs, even though you work in the common main source set. So the perfect approach, or the preferred approach, would be to declare kind of as many, but not too many targets that you would like to support just in a reasonable time, and not intend to change them that much in the future. So think about it twice before starting, and then make it happen. The corresponding configuration might get a bit more complicated once you decide to put platform-specific dependencies. Here on the slide, in Android main source set, we put the Android activity compose dependency, which kind of glues for us the Android and composable stuff. While in JVM part, we put the dependency on the coroutine swing, which is about gluing the front end built with swing with the Kotlin X coroutines and the dispatcher from there. So once we understand the configuration itself, we might go further to the actual Kotlin code and speak about how do we achieve this platform-specific behavior. And as I mentioned, the most common approach is to use the expect functions, which usually might not return nothing, but if you want them to return something, it's preferable to define some interface and declare your functions to return this the object of this interface. So later on each of the platform, for example, on VASP or on Android, you define a proper implementation of this interface with overriding, in this case, this value in the intended way, and you return this instance from the expect functions. Yeah, what's done there is getting the custom behavior for each of the platform target. But what we can do more is not only getting custom behavior, but also during this procedure, making use of the platform-specific APIs. So in this example, which is part of my shopping list application, we have an expect function, which will be called from the common code, which is about sharing the created list with the other users. So when the user is using this application on web, it's expected to go to the window location and use it as a base for the URL of the list, and then append the list ID after it. But when we speak about Android implementation, we not only want to share the ID of the list, but also open this extra window from the bottom to share this list with the others. So user can use, for example, some messaging app to actually share this value with friends or family members. Once we have this understood, we can try to speak about sharing the data models, some core utilities, and some core business logic to be shared between different parts of your systems. This includes the data models, for example. As we can see on the slide, there is shopping list data to be exposed by the server, but to be reused by the client's part. We have single source of truth for both of them, and this is how we not only avoid code duplication for those, but we also get the same behavior for each of the part when it comes, for example, to serialization of those data classes. So we can make use of the Kotlin X serialization multi-platform library, which enables such easy serialization as annotating your data classes with this annotation, and even providing some custom serializers for the fields that are not, let's say, that simple. So there are no default serializers, or which you would like to customize by your own. For example, here I provided a custom serializer for the instant, which is by default serialized as those ISO values, so kind of string value, and I wanted to serialize this as a simple long value, which instant actually is. Last but not least, the shared part is not only about the model, but it's also how this data is sent between servers and clients. And what we usually would do there is we would define some REST APIs and put, for example, the paths of those endpoints in the shared module. But what we can do already with experimental solution, but it's really nice for the projects of type like this one, is the Kotlin X RPC calls, which enables abstracting from the communication layer and just taking care about the business logic which matters for you. So what you end up with is a single, for some, let's say, abstraction, you define single interface with the methods that you're interested in, and that interface is available in the shared part. Because of this, this is available on the server and on the clients. So on the client's part, you get clients automatically generated for this interface, while on the server, what you care about is only implementation of the actual logic for this interface. So, for example, in this case, there's kind of simple implementation of the list creation, where we get the user of the input, get the user's input, and we try to first extract some data from it, because it might be a URL to some cooking recipe from which we would like to extract the ingredients and put them as shopping list items. So you only care about actually defining the logic that you're interested in while implementing this interface on the server side, and the whole communication is brought to you by the Kotlin compiler plugin that's part of this Kotlin X RPC library. What you need to only take care about is making sure that the types that you use in the interface are all serializable, so they can eventually be sent over the network somewhere, and that you declare those as suspending functions. So, for example, client might wait for a slow server, right? Which might be the case, or you might end up returning a flow, so kind of live update of the values from such functions, which is already supported and which I make use of to get the updates of some specific shopping list in my case. If we speak about the server implementation, I'd like to, that's not the multi-platform part, but I'd like to share with you some nice technical solutions and libraries that I tend to use in my project, and one of them is the exposed one, which enables different approaches to doing SQL queries. So there are two approaches supported. One of them is kind of DSL-based queries, and second is ORM-like approach, so editing only the entities fields, and the queries are automatically done for you in background. We can see that such a queries, which is the first approach, might be really familiar to those of you who are SQL developers or have a lot of have been touching SQL a lot in the past. So this looks almost the same as raw SQL, but it's fully typed, and you get auto-completion in IDE for those when writing them. While when you speak about the entities approach, it's as simple as assigning new values to the entity fields, and this get updated by the framework when the transaction is being executed. All these parts are wrapped into Ktor server, which is a really nice solution for providing such a service with Kotlin JVM. And Ktor itself supports a huge number of plugins. I use just a few of them. One of them is, of course, Kotlin X RPC, which enables this nice integration with the server and the RPC interface being declared in the shared part. But also it has really handy DSL for configuring routes. So here at the bottom, I define those RPC endpoints in some extra functions. But what I define extra is, for example, the endpoint that will return the version of the current server. And this is as simple as 2 lines of code which you write and are so easy to understand and to expand with. Yeah, what's extra point there? Ktor also supports being built with the GraalVM native image tool, so you can end up with a binary executable as your server, which is really nice if you consider running it with low memory usage and with fast startup time, which I did in this project too. Once we touch almost all the parts of the server, we might see how the front-end part is built, and there is a lot of composed multi-platform being used, since we intend to have the same UI on each of the platform. So we define this code only once, how those components should behave, and we end up with the exactly same behavior on each of the platform, unless there are some actual that you explicitly define to get custom behavior there. What's nice there is the fact that the whole UI is defined in your code, so it's statically typed, and you can make use of auto-completion or AI completion when building such UI, and all of this stuff is checked at compile time for you, and you decide at which level you integrate with the view models or stuff like this. What's also nice and quite recent thing is the fact that you can define the view models in the shared part, thanks to which you can have exactly the same business logic being executed on all of the clients that you support. The view models are very similar to the view models available on Android, so they integrate really well with the Kotlin X coroutines. We get the view model scope where we would do some HTTP or RPC requests that are intended to be run in background. But thanks to the Kotlin Multiplatform, we might end up in the situation where we would like to build the native to the target UI. So for example, we would like to only share the view models and then provide platform-specific UI on Android and iOS clients. And that's already possible with the help of these mentioned libraries that you might explore, and which I didn't need to because I have UI everywhere the same, but that's something that's that's already happening in the world. To sum this up, I think that I shared with you how easy from the start it's to create a new project with the help of Kotlin Multiplatform. You can go to the single web page and start your journey even today to explore this stuff. And I hope you can try the Compose Hot Reload to expand those ideas that you have in mind and to build your own apps. I think that there is the core of the presentation is avoiding the code duplication. I know that's happening in many places in our projects, and with Kotlin Multiplatform we can really avoid it because it's being compiled to so many targets. Also, thanks to Compose Multiplatform, we can end up with the single source of truth of the application being built to so many front-end clients from a single source of truth. And when it comes to the server part, it's really nice, at least from my perspective, to build such servers with Ktor, but not only, there are also other solutions with the Kotlin JVM, which can benefit a lot from the shared part in the libraries that we provide. The repository that I prepared with the project of the shopping list app contains many other technical details of the project that I wasn't able to cover there, but you can find them listed on the presentation. And for example, I can advertise the screenshot test that I managed to prepare automatic generation of the screenshot that you saw at the beginning. But there are many more, and I'd love you to explore this and share with the others. Thank you a lot, and let's explore.
Okay, thank you so much.